So here I've got a DAC XP Signature, and the report with this one was that the output was very low on all inputs. Now when I looked at it, I could see that there wasn't actually any analog inputs set, so I thought I'd better have a look at that before taking the thing apart. So I've set up an analog input here, and we can actually see as I turn the volume up, I'm getting lots of output there. I've got nearly 2 volts on the peak there, so that's just perfect. So I thought, okay, the analog side's obviously good, we better go and see what's going on in the digital side. So there I've got an optical input on the laser disc, and again I can peak 2 volts there, no problem. So I don't actually see a problem on that, which is a bit puzzling. And if we go and check the other input, the jukebox, this is on the coax. If I set the coax there, then again I've got plenty level, up to 2 volts, no problem at all. So at this point I can't actually see a problem with this unit. Looking on the audio analyzer then, and this is the analog output from one of the digital inputs, and it looks good. Our peak signal there is just above 0 dBV, our noise floor about 135 here, and we do see some a distortion here, but this is basically my input waveform. I'm not using a high sample rate input waveform, and so we just see the quantization there that gives us this distortion. So that's okay, I'm not unhappy with that. So again, this looks like there's no problem here. However, when we switch to the balanced output, and if I reset my measurement there, we can see a very different story here. We see that our main signal is about -20, so we've dropped about 10 times level there, and you know, the output spectrum here is terrible. We've got all these sidebands on the fundamental here, and all these harmonics which are just way too high level. And another clue here we see is that the noise floor is also dropped. It's way down at 150. So there's something going seriously wrong with this balanced output. So that's where we need to focus our investigation now. So we'll open the unit up and have a wee look at what's going on. Let's take a look inside then. And we've seen inside these units before, so there's nothing much new to show here. I do know that this unit has been repaired before, and I can see on some of these boards here, these 3 boards actually, that there's been some capacitors replaced, and you can see we've got these aluminium electrolytic type capacitors here. These are what's normally fitted, and whoever's been in here before has replaced them with, they've soldered on some through-hole parts. Now I can't overly argue with that, because at least they've put in sort of 110 degree parts there, and you know, that's fair enough. I don't know what type of capacitors these are. They're maybe not sort of the highest grade parts in the world, but anyway, these areas they've been looked at. We can see obviously there's a whole bunch of other capacitors here that have never been touched before. So probably our problem is going to be in one of those areas, but let's see. Anyway, what we find is if we just look at the analog section, if we look at the output section, these 2 devices here, these are our left and right volume control devices, and this board is our output board. And what happens is we've got a balanced signal comes out of these volume controls, comes onto this board, and then there's some op-amp circuitry on there that converts that to unbalanced, and we just come out the connectors on the back. For the balanced output, the lines just run through, and in the signature variant anyway, there's only a series resistor between the volume control and the rear panel, and we know that it's the same signal that's driving this unbalanced board. So very peculiar that we've only got a problem on the balanced. Now I do remember we looked at one of these units before, and when we took the board out we saw there was a bunch of mods on there, and I'm going to bet this is the same, because I can see here, you can see that there are footprints for some circuitry, and I can also see that there's some wire mods, they're poking through from the underside. So when we take this board out, we're going to see some interesting things, I think. Anyway, I think the first thing is what we'll do is we'll trace this signal through, and we'll figure out what's going on in that path to upset our balanced output. And then after that, I think the board will come out, and we'll see what we find from there. Let's work through this signal path then. And if I first just check on the unbalanced output, we've got plenty of level there, nice clean signal, everything okay. And then if we look at the balanced output, what we find is we've got our volume control device, there's a series resistor, and then the output connector. So that, there's nothing there, no real circuitry there to cause us any problems. And if I look at the volume control side of the resistor, I've got plenty of level. I've got a noisy signal. Now that may be just part of my measurement here, because I've not got tight grounding going on. And the other thing is there is no filtering in this circuitry, so this may actually be what we get. But ignoring that for now, our level's just fine, so that's all good. If I look at the connector side of the resistor, what we find is we get this low level that we saw before. Very low level, very noisy, horrible signal. So that's very, very peculiar. We've got a small resistor, and this is the effect on the connector side of it. So what's going on there? And if we kind of look at the circuitry that's involved here, we've got our audio output coming from the volume control and the series resistor, and then to the output connector. But we've got this transistor here that's able to shunt that line, and this must be used for some kind of mute or turn on delay, something like that. How it works entirely I can't see from here, because this is obviously unipolar. There's only a single transistor there. And what I find is that this transistor is being driven, and therefore we're kind of shorting that line out. We've got a signal here, resistor, and then we're shorting this to ground. That's why our level's low and it's distorted and all the rest of it. We're pulling too much current through here, as well as shunting it to ground. And it's interesting that this is only on the balanced output, it's not on the unbalanced. So why is this line being driven? And we find that the logic that drives that comes from the front panel controller. But in addition to that, we've got some circuitry that's a power on reset device here, and that's on the 5-volt line. And what this does is it holds the reset line until when you're powering up, the voltage rises to the 5 volts, and it holds that reset line until something like 4.3 volts. And then it's, by that time you're saying, okay, my supply is pretty much there, I'm going to start to turn things on, and it lets go of that reset line after a small time delay. So we've got this device here. But if that line there, if that 5 volts is good, then this shouldn't be a problem. But I do know that it's this line that's holding this transistor in the on state and causing our problems. So why is that? Now, I suppose the first thing, we go and measure our 5 volts. So there we are there, we're reading 5.5 volts, nearly 5.6 volts. So it's way in excess of the sort of 4.3 volt threshold. And you then kind of discount this as being the mechanism when we see that. So that's just a simple DMM test, but really, looking at that, you think, okay, the 5 volts is a little bit high, but it's good enough. However, we need to look deeper. We need to look at that line with the scope. And so, if we go in here, here we are, 2 volts of division. So we can see we've got this very, very noisy signal here that's going somewhere between 4 volts and 6 volts. And that's, this is a 5 volt regulator. How can it possibly be giving us 6 volts out? And if we sort of stretch our time out a little bit, and we trigger, we're triggering there. What we see is we've got this waveform that looks like a ripple, looks like your normal 50 Hz ripple kind of thing. But if we look at the frequency, we can see that that's up 70 something kilohertz. And what's happening here is that the regulator is basically unstable and it's not performing its job. And the reason for that, we can bet, is that we've got some dry capacitors on the output of that regulator somewhere. So that's our common cause for a lot of things. It's just bizarre how it manifests itself here. So we'll go now, we'll look at some of these capacitors and see what's going on. But that's the mechanism. What's happening here is that this voltage is dropping down to 4 volts, and so that power on reset device, it's never letting go of the reset. It keeps resetting, and that's what's holding this line on the output side down, and causing the level to be low and the distortion to be high, etc. Okay, everything's dismantled now, so let's whip this board out and see what awaits us on the underside. Yeah, it's not as bad as I thought actually. The previous one we looked at, there was a bunch of mods down here. So maybe they've just not been done in this variant. But we do see we've got some wire mods up here. And these just seem to be flipping the phase of the balanced output. Obviously when there was an op-amp circuitry in there, it was maybe doing an inversion. And so this kind of crisscross effect just sets the phase as they want it to be. So there we are. So this here is our 5 volt regulator, and so I'm suspecting that that capacitor's in a bad way. So we'll maybe go around here, we'll take a look and see what the ESR meter tells us. I suspect a bunch of these are going to be bad, and we'll probably end up just replacing all of these. So curiously, when I measure this capacitor for ESR anyway, actually reads okay. So that's kind of not what I was expecting. But what we'll find is that there will be several capacitors on the 5 volt line on this board that are in parallel with that guy, and so we're reading the combined effect here. So we'll take that part off the board first. We'll just measure that out of circuit and see what that tells us. I can see there's a bunch of other ones here that are completely dry. There's this guy here, no life left in that at all. It's a very hot area of the board as well, so they're all reading nothing. And when we go onto the digital side, this is where we saw the problem in the last time when we looked at one of these boards. Yeah, so we're getting 10-15 ohms there, so it's pretty rubbish. Similar. So we'll just replace all of these aluminium electrolytics. First of all, we'll take that off board, we'll measure it, see what it looks like. So here's the capacitor off the board then, and if we measure that, we can see there's absolutely nothing there, just the slightest nudge on the meter there. So this is completely dry. And if we measure on the board again over the pads of that capacitor, it still reads good. So this is what's happening there. There's some capacitance on the rest of that board that makes that look good. But as far as the regulator is concerned, it doesn't have any local capacitance to keep it stable, and that's why we're getting these funny, horrible waveform in the output of that regulator. So that can be quite misleading. Testing capacitors in circuits is very easy with the ESR meter, but in this case, if you did that, you'd be kidding yourself on that guy was okay, because it's not. So here's our bunch of replacement parts then, and these are very high grade capacitors we've got here. These are rated at 125 degrees. Normally we move to 105, but these are that good bit better, so they should do a good job on this board and last a good long time. So we'll just work our way around now. We'll replace these, and so we're about halfway there now. We can see all the capacitors with the red caps on the end. And it's quite confusing actually, because you would assume the red cap is the positive end, but it's actually not, it's the negative. So need to be careful in installing them. And You know, it's quite invasive this. We have to take these other boards out, even to get into access some of these areas. So it's quite a laborious job. Now, looking at these plug-in boards where, you know, someone's been here before and replaced these capacitors with through holes, I can see, you know, that some of the traces have been lifted. So I'm not going to replace them. I'm just going to leave them as is. I'll measure them, make sure they're okay. But we'll just stick to replacing these aluminium devices and leave it at that. So I've still got a few more to do here, and then we can install these boards and begin to put it back together then. Alright, so that's all of these aluminium electrolytics replaced, and a real tedious job in this unit. Just getting access to these devices is very difficult, and have to dismantle various other bits to get in there. But anyway, we're done now, and so we can easily slot the board back into the main unit here. And I can see when whoever was in here previously, this there's a sheared screw in this mounting point here, so that's not ideal, but anyway. So there we go, and it's an easy enough job now just to connect these power lines up and the main supply. So we'll do that without screwing it all together and just check our voltages and things, make sure we're all happy before we do the final assembly. Alright then, we're all connected up, and we'll power up now, and we'll just measure that 5 volts that we saw was reading high before, just because of its instability. And what we expect this time is that we should be much more accurate towards the 5 volts. So let's just power up and see how we go. Healthy kick from the transformers there, and there's our 5 volts there, 4.98, so very close, much more accurate now. And you know, I'll check that with the scope obviously, but looking good. And then if we look at the enable for these transistors that were on the output side there that were causing us a problem, with the unit switched off, they should still read 5 volts. And there we are, there, 5 volts. I need another hand now to turn the unit on. When I power up, that voltage should drop negative. There it is there, minus 14. So now I know those transistors are being turned off and our balanced output should be just fine. So that all seems to be working good. I think the next thing now we'll put some signal in and see how they look. Right, so let's first just look at our 5 volt line on the scope. Just make sure it's nice and quiet as we expect it to be. And yeah, so there we are, 2 volts of division, and we've got 2.5 divisions. And previously, you know, we had about 2 volts of junk on that. So that's working just quite happily there. So then if we look at our output, let's first look at the unbalanced output, as we did before. And there I've got plenty level and can vary my volume just fine. And the issue we saw was we couldn't see that same on the balanced output. So let's take a look at the balanced output now. And there we are. So again, I can vary my signal just fine. Do see there's a bunch more digital noise on there, and you know, my suspicion is there that that's just because there's not the same filtering on that balanced output as we have on the unbalanced. So that's obviously a design aspect. We'll have a look in the wideband spectrum on the audio analyzer and see just how that shows up. You know, I'd have liked to have seen some filtering on that, but there we go. So that's all good. Next thing, we'll put it in the audio analyzer, just look at the spectrums, make sure everything's nice and clean there. Alright, looking at the spectrum then, and this is the unbalanced output. Using an optical input here. This is the unbalanced output, and we're running the DAC XP at full level here, and we can see it's just reading maybe about +4 dBV there, and if we go and we ask for the balanced output where we had the problem before, what we'll see is that we get an extra 6 dB on the level, which is correct, and the noise floor rises by the same, and so that's all good. Nice clean spectrum now, so we're quite happy that that balanced output is working just fine. So I'll go through all inputs and outputs there, make sure they're all functioning. But let's just take a look at the wideband spectrum. You know, we mentioned about the kind of digital noise we could see on the scope when we looked at the balanced output. So how does that look in the spectrum? Alright, so we're looking way out in the spectrum here. We're looking out to 1 megahertz, and this is the unbalanced output, and we do see that there's some junk creeps up here above sort of 300-400 kilohertz. And as I say, this is on the unbalanced output where we saw a fairly clean signal on the scope. So let's flick to the balanced output where we did see some junk on the scope. Let's see how that looks. So here's the balanced output, and as we can see, it's very, very quiet all the way up, probably way beyond a megahertz there. It's very quiet. So even though we saw some junk on the scope there, when we actually, you know, I was only looking at a single-ended output on the balanced connector, so I wasn't doing a proper balanced measurement there. When we do the proper balanced measurement here, the common mode rejection of the analyzer just takes any junk away, and we've got a super clean spectrum all the way up there. So even though we did see some junk in the scope, you know, quite happy with that. It looks very, very good here. So that's all good. I'm just going to go through, check all the other inputs and outputs, and then we're probably in a position to play some music. Here we are then, we've got our DAC XP Signature complete with our uprated caps, and everything's behaving good now. And I've paired it with my Mono X300s that we modified recently. This is a good combination. So let's just play some music now, and we'll see how this thing behaves.